To wrap up section 4.3, we'll take a look at what happens when you need to change units in your exponential models. And we'll go back to the example of the water in the ice tray. But now, instead of having checked the temperature every minute, suppose that we had only checked the temperature of the water in our ice tray every 10 minutes. So if we would have done that instead of checking it every 1 minute, we would have gotten a different table of data, like the one that I've written out here. In the first row, I still have time, but now my increases are by 10 minutes. And you'll notice that the decreases in temperature are much larger because we've gone a full 10 minutes between each measurement. So to get the new multiplication factor that corresponds to these changes of 10 minutes, we would have to compute the ratios again as we change time, as we increase time. So for the change from 0 to 10 minutes, we would look at the ratio of 44.5 to 67. So you do this division, and you get 0.64 in your calculator. And I've rounded to 2 decimal places here. And this is different than the multiplication factor, the temperature ratio, that we found for jumps of 1 minute. Remember, that was 0.96. So you should finish the table to make sure that the multiplication factor, this ratio, is going to be constant. So you'd want to look at the change from 10 to 20 minutes and divide these two numbers. And then look at the change from 20 to 30 minutes. And then you'll divide these two numbers, as I did here. And then finish by looking at the change from 30 to 40 minutes and dividing these two numbers, like I did here in this last box. So for each change, the ratio was constant. That means this is still an exponential function. But this multiplication factor is now 0.64. But suppose I still wanted to get the multiplication factor for a minute in time. In order to do that, we'll have to do a little bit of calculation. Because 1 minute is 1/10 of this change, 0 to 10. That means in order to get the minute multiplication factor, I would have to put an exponent of 1 over 10, 1 out of 10, on my multiplication factor for 10 minutes. That's because 1 out of 10 minutes have gone by. So if 20 minutes had gone by, I would put a 2 up here for the 20-minute multiplication factor, and so on and so forth. So you would want to plug in your 10-minute multiplication factor, the 0.64, and then in your calculator, you would probably put on the exponent, 1 over 10. And when you do that, you'll get the minute multiplication factor that we found in the previous video, the 0.96. And again, this is rounded to 2 decimal places.